Now what you're seeing here is not me playing the endless runner game Subway Surfers, but an AI, or more specifically a convolutional neural network, short CNN, with close to 1 million trained parameters that make it adapted to rapidly make decisions on the fly and evade the oncoming obstacles. Now in this video I'll try to give you a good idea what the AI is seeing, how well it performs with its predictions, and how it discovered some game-changing glitches along the way. So Subway Surfers is an endless runner where you run from a growling cop that is chasing you. The game is relatively simple in that there are only 5 possible actions to perform: jumping, rolling, going right and left, and to do nothing, of course. This rather limited action space makes implementing an AI somewhat feasible, but there are still some challenges. I, for instance, don't have access to the source code of the game. That means I cannot easily read from code how fast I'm going, how far an obstacle is, or which lane I'm currently on. Information about the current state of the game that would make implementing self-learning AIs with reinforcement learning a viable option, as it was the case in my project on Icy Tower, for example. The only information the game is giving me here is what you're seeing on screen: consecutive images, or in terms of what a computer understands, differently colored pixels. Now in deep learning, CNNs prove to be very efficient in working with this kind of information, and they are commonly used for image classification. So with this approach we could get a neural network to predict the best action to take for the visual input of each frame. These networks consist of different layers that each serve different purposes for processing the pixel information given by the image. The convolutional layer, for example, applies filters for extracting relevant feature maps, while the pooling layer takes these and further reduces the input. When applied in succession, they help in rapidly filtering the important parts of my images, and finally, the reduced input is passed to a dense layer that is connected with the output, or in our case, with the 5 actions. So with the right architecture and activation functions, this would give me a powerful agent that is capable of making decisions in the game. In theory, the model would process the pixel information of an image and come to a decision which class it most likely belongs to, provided we have trained our model beforehand, of course. In order for such a model to derive rules and knowledge when to predict which class or action, it's gonna need some training data as ground truth, and by some, I mean a lot. So admittedly, I'm not the perfect example to learn from here, but this is what I set out to provide in the first place. For this, I simply needed to play the game for a couple of hours while a program I wrote made screenshots from the game as fast as possible. These images then go into one of the 5 buckets depending on which action I chose at each point in time. Finally, this would give me the needed training images along with their corresponding labels or actions from which a CNN can learn. But to get a robust model that generalizes knowledge well to work for unforeseen states, I needed more training data. So I made use of a little data augmentation trick where I would simply flip my gathered images and change their labels. So after I finally settled on a CNN architecture with several different layers, of which I won't go into detail here, this one was capable of receiving image input and predicting the correct output or action in 85% of all cases. Finally, implementing the AI required some more coding on my part, but it wasn't too hard to get the program to grab screenshots from the game in real time and perform actions according to what the trained model was predicting. What I always find interesting is that with AI, although this one was trained to mimic my playing style, they often do things humans wouldn't. This led to some interesting runs, and the AI even discovered a game-changing bug. And somehow I found this pretty interesting, and this once again showed me how useful AI can be even for playtesting games. Anyways, enough of the talking already. Here is one of the best runs I've captured, and I'm pretty happy with how it turned out in the end. Alright, that's it. Thanks so much for watching, and I'd be happy if you were to let me know what you think about the project.